So this is graphing inequalities. Okay, so the first thing that I want to tell you is when you graph inequalities, okay, you're going to, there's a couple things, okay, you still treat these like this. And what is this? Who remembers this? What is this? Slope-intercept form. So you're going to treat it like slope-intercept form, okay? You're not going to come up with an exact solution, okay? You're going to come up with some answers that might be a solution. Does that make sense? Okay? So when you have an inequality, first of all, you're going to have this or this, okay? Less than or greater than, okay? How many have ever seen this? What does that mean? That means less than or equal to, okay? This means less than or equal to. So what would this mean? Greater than or equal to, right? So that word or, what does that imply? If something is, let's just say I saw this. If I have this, but what is a number that is less than negative 3? Don't say negative 2. Negative 4. Or anything. X can be anything as long as what? It's less than negative 3. Does that make sense? Okay. If I said X equals negative 3, what is the only thing X can be? Negative 3. But if I said X is less than or equal to, that means can X be negative 3? But can X be negative 273? It can be. So it can be any of those. Okay. So when I have an inequality, okay, let's say, um, let's start with, well, let me show you some more. Does everybody have that copied down? Okay. So when you're graphing, okay, and this is kind of important, these are all going to be linear, okay? Meaning, when I say linear, what does that mean? They form a straight line, okay? When graphing linear inequalities, if there is a less than or greater than, use a solid line, okay? Use a solid line. If less than or equal to or greater than or equal to, use a dotted line. Sorry, hold on. Guys, I messed that up. It's the other way around. Switch these. It's a solid line if it's less than or equal to, or it's a dotted line if it is just equal to, or just less than or greater than. I'm sorry. So let's say I've got an equation that looks like this. Y is greater than 2x plus 1. Okay, write that down. Write that inequality down. Y is greater than 2x plus 1. What did I tell you to treat this like? Like slope-intercept, okay? So if I pretend that this is slope-intercept, that would be the same as saying y equals 2x plus 1, right? So what would my y-intercept be on this inequality? What's my y-intercept? You guys all agree it's 1? And what would my slope be on this? 2 over 1, right? You with me so far? Okay, so here's what I'm going to do. The first thing I do, step 1, is I'm going to graph this, okay? So I'm going to graph this. Now, because there is a less than or greater than sign here, am I going to come up with an exact answer? No, but I'm going to come up with what could be an answer, okay? So the first thing, or step 1, okay, is to graph. Okay, so we're going to graph this, all right? So what was my y-intercept is 1. So where's that going to be on here? Right there. And what was my slope? My y-intercept was 1, and my slope was 2 over 1. Okay, so I would go up 2 over 1. Does everybody understand that? Okay, so up 2 over 1. Now, normally, what do you do here? You put a line there, right? But this is just greater than or less than. So what's that going to be? Dotted line, okay? So when I put my line here, okay, let's move this over to a dotted line, okay? Okay, so I'm going to put a dotted line there on my graph, okay? Now the thing is, whenever you have an inequality, okay, you're always going to shade one side of the graph or the other, okay? And I'll show you what that means. Okay, so let's go back to this. Step 2, okay, is to shade. Now, what do you mean shade? Okay, here's what you're going to do, all right? When you shade, you're going to use 0, 0 as a test point. Okay? Use 0, 0 as a test point. So, if I say use 0, 0, what does that mean? That means I'm going to replace y with 0 and what? X with 0. Okay? So if I do that, if I replace this y with a 0, that means 0, right? And then I have greater than 2 times 0 plus 1. Well, what's 2 times 0? 0. What's 0 plus 1? 1. So look at this inequality. Is it true? Is 0 greater than 1? No. Okay. No, it's not true. Okay? So what you're going to do is you're going to go back over to your graph. Okay? 0, 0 is right here. Okay? That means that is not true. Okay? If it is true, you shade the side that has the 0, 0 on it. See the line? See how there's a side of that line? What side of this line is 0, 0 on? This side, right? If that was true, I shade that side. Was it false? It was false. So I'm going to shade this side. And all you need to do is put like lines here. And what that means is any point on this shaded area would make that equation true. Carson, pick a point, any point on this side of the shaded area. Anywhere. Negative 4, 3. So right here. Okay? Let's go back and plug that in. Okay? We're going to plug that in. You don't have to do the prove it point, but you have to do the other stuff. Okay? What did you say, negative 4, 3? Okay, so if I plug that in, that means x is negative 4, y is what? 3. Whoops. Okay, so that means y is greater than 2x plus 1. So y is 3 is greater than 2 times negative 4 plus 1. What's 2 times negative 4? Negative 8 plus 1. What's negative 8 plus 1? So is that true? Is 3 greater than negative 7? Yes, it is. Okay? So any point that you choose in that shaded area is going to make this inequality true. Okay? A little bit complicated at first, but you kind of understand how we did this. Okay, let's try another one. Can I erase all this? You sure? All right. So let's say I've got an inequality that looks like this. Okay? Let me erase this stuff. All right. Let's say I got this one. Y is greater than or equal to negative 1/3 x plus 2 plus 1. All right. So from here, what can I figure out? What from here can I use to graph this? Ben? Okay. So what's my y-intercept here? Class, tell me on 3. 1, 2, 3. 2. What's my slope? Okay. Everybody understand where those came from, right? Okay. This is always going to be my y-intercept. This is always going to be my slope. Okay. So let's take this information, y-intercept of 2, and graph it. Is that up 2 or down 2? Up 2, and I'm going to put my point. Okay? And then I have a slope of negative 1, 3. So how am I going to graph that? Down 1 over 3. Good. All right. Am I going to use a dotted line or a solid line? solid because it is or equal to. Okay? So I'm going to go ahead and put my line here. Does it have to be straight? What do you mean? Oh, no. No, no, no. It doesn't have to be super duper accurate. No, because they're not going to intersect anything. Okay. All right. So what's my next step? I graphed it. What was the next point? To shade, and I need to use a test point, right? What's the best test point to use? 0, 0. Okay? So that means I'm going to do 0, 0. That means y is greater than or equal to negative 1/3 x plus 2. That's the right over 3. Okay. So 0 is greater than or equal to negative 1/3 times 0 plus 2. What's negative 1/3 times 0? And what's 0 plus 2? Is 0 greater than or equal to 2? No. Okay, so if it's not, what side am I going to shade over here? Would I shade this side? Because that's where what is? 0, 0, okay? So I'm going to shade what side? Okay? And that's all that that means, okay? Anything from here up, and I'm not going to make you test it, but anything in that graph that I put in that shaded area would make that inequality true. Are you kind of understanding it? Okay, question. Yeah, I can show you one that's true. Uh-huh. Okay, I'll show you one that's true. Okay, you shade the side with the point that's true. Yeah. Okay, so look, let's try this one. Okay, if I had this inequality, y is less than or equal to negative 3 over 2. Let's do this one. Let's do negative. Let's do negative 3. Negative 3x. Um, say plus 4. All right. What can I take from here? What's my y-intercept? 4. What's my slope? Negative 3 over 1. Okay, good. So can I use this to go graph this? Okay. Let's go over here and graph this. My y-intercept is 4, so where's that going to be? Up there. Well, my slope was negative 3 over 1. If I go down 3 over 1. Okay. Is this going to be a dotted or solid line? Solid because it's or equal to. Okay. I'm going to make a solid line here. All right. Let's go back and plug it in. What do I use for a test point? 0, 0. Okay, so I'm going to say 0 is less than or equal to negative 3 times 0 plus 4. Okay. 0 is less than or what's negative 3 times 0? 0 plus 4 is 0 less than or equal to 4? Yes, it is. So in this case, it is true. So if it's true, then I shade the side where this point is. So go back to your graph. Okay, which side is the 0, 0 on? This side. So which side is going to be shaded on this one? Okay. Does that make sense? Not that difficult, right? So somebody had a question. Carson, ask me this question. What if it goes through the point 0, 0? Excellent question, Carson. Okay. If that happens, if it's going through the point 0, 0, you can choose any point. Okay. If it goes through 0, 0 and it doesn't go through 1, 1, choose 1, 1. Okay. Because that's an easy point to test. You can choose any point to test, and whatever side it makes it true, that's the side you shade. Okay. Does that make sense? I don't think any of them on your worksheet go through 0, 0. Okay. All right. Now, what if? Are we good so far? Yeah. Oh, this part's easy. But it's the truth. Okay, what if all I have is this? Let's say y is less than or equal to negative 5. And that's all you have. Okay? Well, what do you think that means? Okay, that means no matter what, where's negative 5 on the y-axis? Right here. Right? what would tell me that y is less than or equal to negative 5? Which side? First of all, if this is all I'm given is y, this is going to be a straight line. Okay? Straight line. It won't, because there's no other points. Okay? Now, which side of this line would make this true? If I shaded this side, are those less than or equal to negative 5, or this side? How many of you guys say up? How many of you guys say down? Yeah, because all of these this way are what? Are those all less than or equal to negative 5? Yes. Does that make sense? Okay. What if I had this? What if all I was given was this? X is greater than negative 2. Okay, where's negative 2 on here? On the x-axis. Right here. There's no other points, so that line's going to be going where? Straight up and down, but is it going to be dotted or solid? Dotted. Okay? So this thing's going to look like that. Except this line is dotted. Now we do. Okay. Which side of this would make this true? If I shade this side, is that greater than negative 2? Or would I shade this side? So if you say to the right, raise your hand. If you say to the left, raise your hand. Okay. If I go to the left, any point over here, let's say this point. What's the x on this one? Negative 5. Is that true here? Is negative 5 greater than negative 2? No. So what side should be shaded? This side. Okay. Does that make sense? Yes? Do you want to do another one, or is that good? Okay. On your worksheet, there are 10 problems. I only want you to do 1 through 8. Okay? Because I don't have time to show you how to do 9 and 10. You can try them. Good luck.